There are more than 200 million insects for every human being living on planet Earth today. As you sit listening to this sentence, between 1 and 10 trillion insects are shuffling and crawling and flapping around on the planet, outnumbering the grains of sand on all the world's beaches. Like it or not, they have you surrounded, because Earth is the planet of the insects. There are so very many of them that it's difficult to take it in, and they are everywhere, in forests and lakes, meadows and rivers, tundra and mountains. Stoneflies live in the chilly heights of the Himalayas at altitudes of 6,000 meters, while mosquito larvae inhabit the piping hot springs of Yellowstone, where temperatures exceed 50 degrees centigrade. In the eternal darkness of the world's deepest caverns live blind cave midges. Insects also live in baptismal fonts, computers, oil puddles, and in the acid and bile of a horse's stomach. They live in deserts, beneath the ice on frozen seas, in the snow, and in the nostrils of walruses. Insects live on all continents, although they are admittedly represented by only a single species on Antarctica, a flightless midge that kicks the bucket if the temperature happens to creep more than 10 degrees above zero for any length of time. There are even insects in the sea. Seals and penguins have various kinds of lice in their hides, which remain in place when their hosts dive beneath the surface. And we mustn't forget the louse that lives in a pelican's pouch, or the water striders who spend their lives scudding six-legged across the open sea. Insects may be tiny, but their achievements are far from trifling. Long before human beings set foot on this planet, insects had already taken up agriculture and animal husbandry. Termites grow fungus for food, while ants keep aphids as dairy cattle. Wasps were the first creatures to make paper from cellulose, and caddisfly larvae were catching other creatures in net-like webs millions of years before we humans managed to weave our first fishing nets. Insects solved complicated problems of aerodynamics and navigation several million years ago, and learnt, if not how to tame fire, then at least how to tame light, even within their own bodies. Insects assemble. Whether we opt to count them by individual or species, there are good grounds for claiming that insects are the most successful class of animal on the planet. Not only are there incredible numbers of individual insects, they also account for well over half of all known multicellular species. They come in around 1 million different variants. This means that you could have an Insect of the Month calendar featuring a new species every single month for more than 80,000 years. From A to Z, insects impress with their species richness. Ants, bumblebees, cicadas, dragonflies, earwigs, fireflies, grasshoppers, honeybees, inchworms, jewel beetles, katydids, lacewings, mayflies, nits, owl moths, praying mantises, queen butterflies, rice weevils, stink bugs, termites, urania moths, velvet ants, wasps, xylophagus beetles, yellow mealworms, and zebra butterflies. Let's do a quick thought experiment. To get an impression of how species diversity is distributed among different groups of species, imagine if all the world's known species, big and small alike, were given UN membership. It would be an awfully tight squeeze in the assembly chambers, because even if there were only a single representative for every species, that would still add up to well over 1.5 million representatives. Let's say we distributed power and voting rights in this UN of biodiversity according to the number of species in the different species groups. That would throw up new and unusual patterns, largely because insects would dominate, comprising more than half of all votes. And that's before we consider all the other small species, such as spiders, snails, roundworms and the like, which alone would account for 1/5 of the votes. Next up, plant species of all kinds would total roughly 16%, while known species of fungus and lichen would command around 5% of votes. But where do we fit into this picture? When we look at species diversity like this, humanity doesn't amount to much. Even if we were counted along with all the rest of the world's vertebrates, with animals like elk and mice, fish, birds, snakes and frogs, we would still end up with a minuscule share of power, constituting a mere 3% of known species diversity. In other words, we humans are totally dependent on a host of tiny, anonymous species, a significant proportion of which are insects. Dwarf fairies and biblical giants. Insects come in all shapes and hues, spanning a range of sizes that is barely matched in any other class of animal. The world's tiniest insects, fairy wasps, live out the whole of their larval existence inside the eggs of other insects, which gives you a good idea of just how small they are. One of them, the teeny little Kikiki-huna wasp, is so tiny at 0.16 millimeters that you can't even see it. It takes its name from the official Polynesian language spoken on Hawaii, one of the places where it is found. Logically enough, it means something like tiny little dot. A sister species among the dwarf wasps has an even prettier name. Tinkerbella nana takes its genus name from the fairy in Peter Pan, while the species name Nana is a pun referring to both nanos, the Greek word for dwarf, and Nana, the name of the dog in Peter Pan. The Tinkerbell wasp is so small that it can land on the tip of a human hair. It's a giant step from there to our biggest insects. There are several rivals for this title, depending on what you take biggest to mean. If we're talking longest, then the winner is the Chinese stick insect, Phrygianistria chinensis zhao. At 62.4 centimetres, it's longer than your forearm. That said, it's no thicker than an index finger. The subspecies was named for entomologist Zhao Li, who spent 6 years of his life hunting down the super stick insect after a tip-off from locals in the Guangxi region of southern China. But if we're talking about the heaviest insect, the Goliath beetle is well placed. The larvae of this African giant can weigh up to 100 grams, roughly the same as a blackbird. The beetle was named after Goliath, the 10-foot giant of biblical fame who struck terror into the hearts of the Israelites, but was nonetheless slain by a stripling called David, aided only by a sling and a fair amount of help from friends in high places. The very first insects predate the dinosaurs. Insects have been around for a long time, infinitely longer than us humans. It's difficult to get a proper grasp on deep time, eons and eras, millions and billions of years. So perhaps it won't mean all that much if I say that the first insects saw the light of day around 479 million years ago. Maybe it's more helpful to point out that insects saw the dinosaurs both come and go by a long margin. Once upon a time, long, long ago, the first plants and animals emerged from the sea and onto dry land. It was a revolution for life on Earth. Imagine if we could have filmed this fateful moment. What an iconic video clip that would be. One small step for bugs, one giant leap for life on Earth. Unfortunately, we'll have to settle for tracking the entrepreneurs of the insect world using fossils and our own fertile imagination. Think back to the Earth's earliest days. A few million years have passed since the first adventurous bugs poked their heads out of the sea and decided to check out new, drier neighbourhoods. We're in the Devonian period, somewhat anonymously sandwiched between two better-known eras, the Cambro-Silurian period, consisting of the Cambrian, Ordovician and Silurian, which gave rise to the limestone-rich areas around Oslo, Norway, and the Carboniferous period, part of the very basis for our fossil fuel-dependent society, with all its attendant wealth and climate change. Evolution has shifted into top gear, and the first insect is now a fact. Down there on the ground, amid the bracken and the plants shaped like crow's feet, shuffles a tiny, six-legged creature with 3 body segments and 2 small antennae. It is the planet's first ever insect, taking the first small steps towards total world domination by its kind. The close interaction between insects and other life forms was crucial from their very first day on dry land. Land plants improved the life chances of insects and other bugs by providing them with sustenance up there on the stony, barren earth. In return, the bugs improved the plants' life chances by recycling the nutrition in dead plant tissue and creating soil for new growth. The wonder of wings. One important reason for insects' enormous success is that they can fly. What a fantastic innovation that must have been around 400 million years ago. Now insects had access to something totally unique. Equipped with wings, they could reach the nutrition up in the plants more efficiently, while simultaneously avoiding earthbound enemies. For the more adventurous, wings offered brand new opportunities to disperse to pastures new. Access to airspace also influenced choice of partner, giving insects undreamed of opportunities to flaunt their best features in new, sky-high pickup joints. We don't know exactly when wings first developed. Perhaps they evolved from outgrowths on the thoracic area, outgrowths that may have served as solar collectors or a means of stabilizing the body after a jump or a fall. Perhaps the wings evolved from gills. Regardless, the most important point here is that insects discovered that these gadgets of theirs were also brilliant for gliding down from trees or high plants. Insects with well-developed wing nubs got more food, lived longer, and as a result, had more offspring, which in turn inherited these super wing nubs. In this way, evolution ensured that wings became commonplace, and at a pretty rapid rate too, in the context of geological timescales. Soon the air was alive with all manner of shimmering, whirring wings. One point is crucial to understanding how wildly successful wings were for the early insects. Nobody else could fly. There were not yet any birds, bats or pterosaurs, and they would be a long time coming. This meant that insects had global dominance of the air for more than 150 million years. In comparison, our own species, Homo sapiens, has spent a total of just 200,000 short years on the planet. Insects have survived 5 rounds of mass extinction. The dinosaurs first staggered out into the world after the third of these, around 240 million years ago. So next time you catch yourself thinking how irritating an insect is, bear in mind that this animal class has been on the planet since long before the dinosaurs. That alone merits a little respect, if you ask me.